Okay, we're now ready to return to our original problem of the little cart, and we're pulling with a force F in one direction, and the cart is going to move horizontally, and the question is how much of that force is actually going to be used to move the little cart forward. And we came up with a solution before, and what we said was that it's basically going to be force times cosine of theta is going to be equal to the force that's applied to move the cart forward. But now let's reformulate this in terms of vectors. And what we're going to do here is let's call this a vector u. Okay? And so that direction has a direction and a magnitude. And in this case, of course, u's magnitude is equal to the force. Okay? And then we have a vector v, which is some vector that's in the direction of the movement of the cart. So then how would we reformulate this equation in terms of our vector? Well, oh, and by the way, one thing we should clear up a little bit. Let me just draw this out over here. Here is our u, and here is some v in the right direction. What we're going to be doing to make it proper vector speak is we're going to find the projection of the vector u onto the vector v, and that will be equal to this little segment right here. Okay? That's the projection of this vector onto this vector. Alright, so that's the right way to put that. So we can say that the projection of onto v of the vector u is equal to, well, let's see here. It's going to be we know the answer is going to be something on this form. So we know that we're going to need to have the magnitude of the force vector times cosine of theta, and then it's got to be applied in the correct direction. We have the vector v, so we just have to rewrite that as a unit vector in the right direction, and of course we already know that that's just v divided by the magnitude of v. Alright? But we still got this unfortunate cosine of theta. But wait a minute, if we go back up here, we know what the cosine of theta is equal to. It's just u dot v over the magnitude of u times the magnitude of v. So let's substitute that in. So we get u magnitude u dot v over magnitude of u times the magnitude of v times v divided by the magnitude of v. And then of course this can cancel with this, and this is multiplied by that, so we get something that looks like equals u dot v divided by v squared, the magnitude of v squared, times v. And remember, I put this little thing, maybe I should just use a little multiplying asterisk or something, because this v cannot come over here and multiply by this v, and you don't get u dot v squared. That dot process is different from multiplication, obviously. But anyway, this then is an equation for our projection on v of the vector u.